Then if I have 40 devices, so I only need 40 IP addresses, right? There is something that I'm not. Uh, okay, now, yeah, let's see some problems without subnetting. What is happening here? Uh, First I have an IP, right? So I have 192.168. This is going to be my mask. Yeah. So if I have a IP and a mask, then how am I calculating this? Okay, so this is basically my mask, right? So this is okay. This is going to indicate my network bits. Ah, I see. So then the total IP address how is calculated is, so I have 32 minus 23, right? So that is, I have 9 hosts. Total IP is equal to 2 power host. So that is 2 power 9. That is equivalent to 512. And then in this, I have how many usable IPs I have? I have 2 usable IPs, right? One is my broadcast, another is my network, right? So then this is going to be 510. Okay. Um, I understood that now. So now, okay, let's say I assign. So how is this wastage happening? Okay, one thing is I only have okay, so I have here 510 and then I need only uh I only need 200, right? So I guess 300 ton odd IP are getting wasted. Uh, so if I'm having 200 devices, uh, then my formula is going to be 2n power minus 2 is going to 200, right? This minus 2 is basically for removing two addresses. So then this is 2 power n that is greater than or equal to 202. So then the nearest power of 2 that I had is 2 power 8, that is going to give me 256, out of which 2 are going to be unusable, right? So I'm going to have this is 255 and this is 254, right? Okay. So I get host bits. Yeah. So this is basically indicate my host bits. So I need 8 host bits. So if I need 8 host bits, then my network bits will be 24, right? This is my 24 network bits, and then mask will be 55.255.255.0. So total IPs that I have now um, is 256, out of which only uh, one is reserved here, one is reserved here, right? So I have in total 254 reusable IPs. So not reusable, I only have 254 usable IPs. Now, so what is going to happen here is this is basically using subnetting, right? What if I don't do subnetting? Then I have so each class is having its okay. Let's see. I guess each class is getting its own subnet or something. There is something called as, let's see. Okay, I fixed ABC. Let's see an example here. Huh. I'm not understanding why we are still splitting that. Oh, I see what's happening now. So when we go to classful addressing, okay, the network bits are fixed. So every class is going to have a default mask. Um, Okay. Okay. First is basically masking. So we have something called as masking that occurs. The job of masking is basically to hide, or it is to separate the network from the host person. So basically, we are going to separate network. We are going to separate these two things out, right? So it is a 32-bit number used to separate the network portion from the host portion of an IP address, right? Okay. So then, for example, I have an IP address. So this is my IP address. So each class has a specific okay. So by masking, yeah, because first we need to enter the network, right? Okay. So why we do this? First to enter the network, and then we need to go to the specific device, right? So we from the IP we need to do these two things. So to separate it out, we are going to use one basically is called as the mask, and other is basically when we do a logical and we get the result, right? Okay. Now what is going to happen here is in class full uh, class is going to determine how many bits are network bits, and the mask is going to be fixed. For example, so the class determines how many bits are network bits. So when I'm going to do class, so each class will have a each class determines how many bits are network bits, and mask is fixed depending on the class. The device can't customize the subnet. Okay. There is no customization on subnets over here. So if I do classful IP addressing, how is it going to have wastage? Okay, so for example, let's see an IP address. Suppose our organization has got the IP address say 192.168.1.0. So now the first bits are going to determine the first octet determines the class. So this is class C. The mask of class C is uh /24, right? So basically that is okay. This is 255.255.255.0. Okay. So now how to calculate the total IPs? Oh yeah, no, this is something. Okay. So when I do the logical AND of this, what do I get? Mm, oh yeah, so if this is 24, so then I can say this is representing my network bits and I have 8 host bits, right? When I have 8 host bits, then 2 power 8 is equal to my IP address, right? So I have total 256 IP addresses, out of which only two uh, two are going to be reserved, right? So one is going to be my network address, another is going to be my broadcast address. So I have in all 255 IP addresses available, right? Okay. Uh, so this is not a bad thing, right? So instead, what should you do is we are giving the whole block 24, that is 254 to each department. So so 80% is almost unused. Basically, when we do this, so now let's come to our block. So say we need 40 IPs per department. Now under classful, you have to give a whole 24 block, right? So we have to assign entire 24 block. So basically for 5 departments, we need uh 5 into /24 blocks. So so this is like we are assigning 254 IPs to each of the 5 departments. Uh, but in reality, we don't need that many, right? In reality, we only need 40 IPs, right? That are being used at a time. Also, I'm assigning each department a block. Yeah, so each block is going to get 254, right? We don't want uh, that many addresses to be assigned. So what we do is we need to allocate more uh, yeah, so like we only need 40, but instead of 40 we are assigning 254, right? So that is a drawback. I don't know why it's just give me 1 minute. Yeah, so basically we are wasting your IP addresses. So basically 254 to each 4 block sites. So we are wasting addresses. So basically we are having these many addresses, right? But we only need to we only need how many? 200. Like we only need like 40. So there's a lot of wastage that is happening here. The problem why is this wastage happening is because this is fixed here. This mask and this is getting fixed. So now what we do is we use something. So we need to change this. This is what is controlling the wastage, right? So we make a variable mask here. This mask decides how many bits out of my IP are going to be reserved for the host and for the network, right? So how many are for host and how many are for what do you say, network. So I'm going to that is going to be taken from this, right? Oh. So basically what we are changing is we are making a variable subnet mask. Yeah, basically we are going to vary the subnet mask to create a smaller or larger network based on need. Let's understand what does subnetting. Subnetting, we are dividing the company network into smaller isolated parts. We are splitting up the IP address range to assign departments their own subnetwork. We are splitting the IP address. Oh, I see what's happening here. So instead of allocating blocks to each department, we are not going to do that. Instead, we are going to identify. Instead, we are going to create smaller multiple subnets. Yeah, basically, we are going to vary the subnet mask. That's what it means. So instead of allocating block to each department, um, yeah, so we're not allocating complete blocks. We are subnetting to split the main IP network into small subnets, and then each department is then assigned it's the subnet that it needs based on its size. Based on how many devices are connecting, we are doing that. And the way to calculate is I just showed you. Mm, but then there is one more solution, right? There is one more problem that we are facing here. Okay. The problem is IP addresses are still available, limited, right? Even though you do subnetting does not. Um, the only drawback that subnetting overcomes it does not allow IP wastage. Like it reduces the IP wastage. But then still, like the IPv4 has a limit, right? Has a limit because it is made up of 32 bits, right? So at a time we can only have uh, these many possible IP addresses, right? But still our devices are working on IP address. So what that is basically, but the total number of people that use internet today is approximately 4.3 billion, right? And this number is smaller than 4.3. So then what we do is basically, so then how do we solve the issue? Like what if what we do is we kind of use something called as a public and private network. So a private network is basically we kind of divide the network into two types, a private and a public network. So like in 1918 itself we understood that someday we will be running out of IP addresses, so there should be some mechanism by which we allow reusability of IP addresses, right? So to have this reusability in place, what we do is we break down our IP addresses as two types. So I have a public IP and I have a private. So we do a public, and then the other what we do is basically we have a private IP in place, right? So we have this public private partnership. So what we do is certain addresses are then reserved for private IP ranges. For example, so what we do is basically what I'm trying to say is, um, so if you have a modem here, right, and you are going to connect to this modem, then the devices connected to this, the devices connected on this line, these are all private IPs. These are going to be private, and this is the public IP that is going to be visible. So this is going to be my public IP, which is visible from the outside. You cannot see the private IPs inside. There is something called as a network to address translation that does that public to private mapping. So what? But then, so these addresses have been reserved. Like there are certain reserved addresses. There are three main private IP ranges. So we have like RFC has fixed these private IPs. So either it could be the first range would be from 10.0.0.0 to my to 10.0.0 10.255.255.255. The other will be 172.16.0.0 to 172.31.255.255. The third IP range that we are going to have is 192.168.0.0 to 255.255. No, that is to um 192.168.255.255. So basically these are the private IP ranges that have been already specified by RFC, right? So RFC is basically a governing standard. The thing that I'm trying to understand is why we have reserved only them. First is basically it's very easily to recognize and um, allocate, right? These are non-routable. Like if you send data here, it's going to be inside. Okay, I guess that is all for this lecture. I'll see you guys in the next one. We'll see little bit TCP UDP handshake and then we'll be wrapping it up. So yeah, that thanks. That's all for this lecture. Please subscribe to my channel. So basically by subnetting, but instead of allocating those classes to each blocks, we kind of divide the main IP that is allocated to different smaller subnets. The way that subnetting we do is there is a mathematical formula, right, to do that, which I showed you. Okay, so I guess that is all for this session. Hope you guys liked it, and please subscribe, and we'll see you in the next one. Till that time, take care. Bye bye.